Alright, we're starting a new number. We're in the 5, so that means that we're kind of starting a new unit, but it's just a continuation on something that we've already been doing, talking about quadratic. The only thing that's new in this title is inequalities. Now, I just want us to recall something. Inequalities. If I have an inequality like this, x is greater than 5, that means that all x's have to be greater than 5. What happens if I go like this? It says all x's must be greater than or equal to 5. So 5 is included in that answer. The difference between this and this doesn't feel very significant, but it includes a number that one of them doesn't. So the answers are slightly different. I just want to remind ourselves of one rule, algebraic rule that sometimes comes up when dealing with inequalities. If I have something like negative x is less than 2, when we isolate this x all by its lonesome, we want to multiply by both sides by negative 1. What we have to do is we need to flip. So the number becomes, if I multiply this side by negative 1, it just becomes x. This one becomes negative 2, but because we're multiplying or dividing, okay, not adding or subtracting, guys, not subtracting or adding negative numbers, it's just when we're multiplying and dividing that this flip thing happens. So essentially what we want to do, guys, when we're looking at quadratic inequalities in one variable, we just want to see for which domain, so for which x variables, does a certain quadratic exist. So if I drew a quadratic that looked like this, so if I said, where is this quadratic positive? Oh, it's positive here and here. So how would that translate to x values? Well, it's not really helpful here. Say this is 1 and this is negative 6. Well, we would say for x that's that's less than or equal to, because we have a closed dot here, less than or equal to negative 6, or x is greater than or equal to 1. That's it. The only thing that we're going to be doing that's a little bit more complicated than this is we're going to use algebra to figure it out. So what we need to figure out is first, what are those critical points? What are those zeros? Where does it switch from being positive to negative? I just want to give us a quadratic definition of a quadratic inequality in one variable, and this is just in general form. So we can either see it as ax squared plus bx plus c is greater than 0, or ax squared plus bx plus c is greater than or equal to 0. The difference between these two things is this includes it, so we use solid dots on a number line. You'll see what I mean in a bit. Solid dots on the number line, whereas this one we would use an open dot because it doesn't include, okay? Or we can see another way. We can say ax squared plus bx plus c is less than 0. So this is where it's negative here. Or ax squared plus bx plus c is less than or equal to 0. So then it would include those 0 points. Okay, so that's the intro. On to examples next.